Good morning, everyone. Now we're going to talk about immunohematology. Now, this is more focused about in immunology. Now, first, what is immunohematology? So, immunohematology is the study of immunologic reactions involving all components of blood, deals with antigens, antibodies, and antigen antibody reaction. Now, this is only a simple overview. Now, first, what is or how can this immunohematology study can be applied in? It can be used in the transfusion of blood and its components, the diagnosis, prevention, and management of immunization associated with pregnancy, leukocyte testing for organ transplantation, laboratory resolution of parentage problems. Now, there are only two results in immunohematology, which is called agglutination and hemolysis. So, agglutination, it may happen when a surface antigen meets an opposing antibodies. Agglutination is the clumping, hemolysis is the breaking or the shrinkage. Now, there are also types, which is called complete antibodies. Antibody plus RBC with antigen connecting together the antibody, which mean they only have one antibody, which is what we call complete antibodies, while antibodies plus RBC with antigen has its own antibody is what we call incomplete antibodies. Now, first, blood group systems. We will cover ABO blood group and RH blood group systems and others, Diamond S, II, Duffy, Kell, Kidd, P, Lutheran, and Lewis. First, the ABO blood groups. ABO blood group, which was first discovered by Landsteiner in 1900. Now, this knowledge is most significant for transfusion practice. It is important to know the ABO compatibility is essential before other pre-transfusion test is performed because an error can have a a transfusion reaction. ABO antigens are the only ages for which reciprocal antibodies consistently and predictably exist in serum of normal individuals. Now, this is a simple table. Blood group AB, ABO. Each of these has its own RBC, AG, AB, AB, and while O is none. So since O is none, it can go to anti-A, anti-B, anti-A, and B. So we will know further about these things. First, group A, it expresses A antigen on RBC surface. Genotypes AA or AO have naturally occurring clinically significant predominantly IgM with a small amount of IgG antibodies against type B or anti-B. So subgroups A1, 80%, A2, 20% significant. Some with A2 have antibodies against the A1 subgroup. Again, to the group B, it also expresses BAG on RBC surface, BB genotypes BB or BO, naturally occurring, clinically significant, predominantly IgM with a small amount of IgG antibodies against type A cells, which is very common. Now, again, the most important part, the group O. Group O have neither A nor B antigens on their RBC. Genotype OO, which can be called universal donors, have naturally occurring, clinically significant, very high titer anti-A, anti-B, and anti-AB antibodies. Maternal anti-A and B can cross the placenta to cause hemolytic disease of the newborn. Group O cells have the most H antigen. Now, we will not dive in this deeper since we all know that there's A mine or A plus or B minus and B plus and also O mine and O plus. Now, AB, group AB, expresses A and B Ag on RBC surface, genotypes A1b or A2b, however, have no ABO antibodies. So this can be universal recipients. So it cannot donate blood, or it is not a universal donor, but it can be a universal recipient. So it can receive different blood groups. Now again, so this is a simple example. Blood test type AB, AB. There's no agglutination. Type B, agglutination. Type AB contains agglutination A and B. Type B contains agglutination B. This one. Agglutination A, clumping. Type O contains no agglutination. Now, there are different types of testing. So the reverse grouping or typing, also called serum or back typing, uses patient serum versus commercial A1 and B cells. So this analyzes patient serum for the presence of anti-A and anti-B antibodies. ABO blood group testing. Testing for antibodies is not reliable until 6 months of age. Newborn serum may contain maternal IgG, anti-A, or anti-B. Now, RH blood group, or the RH system. Now, in the late 1930s, it was discovered that the sera of most women who gave birth to infants with hemolytic disease of the newborns contains an antibody that reacted with the red blood cells. Now, it is important to know the RH blood group or RH systems. Antigens of the RH system is now known to have many antigens. In addition, the one originally described and several nomenclature systems were developed for practical purposes. Now, RH blood group is a complex blood group with less than 50 described antigens. Rhesus monkey, DAG is more potent, no natural AB against RH. Nomenclature systems, which is the Fisher race, English, or winner, which is American. So the Fisher race is now used almost exclusively. The Fisher race is performed by combinations of 3 pairs of allelic genes, CC, DD, and EE. This was later modified to a model that proposed a single genetic locus with 3 subloci. Again, RH blood groups, the Fisher race. The D, C, and E. 5 major antigens, D, C, E, C, E. Closely linked genes. Now, for the winner, single gene, R1RH, the AG, then the AB antibody, the antigen, the antibody, the 5 major antigens. Now, for testing for DRH0 is the most common RH test performed. RH positive simply means D positive. D antigens are potent immunogens of D negative patients. 80% will develop an anti-D when transfused with a single unit of D positive. Now, there are other blood group systems, the KEL, K, Duffy, FY, KID, JKA or B, MNSS, P, Lewis, LE, Lutheran, LU. Now, what is the importance of other blood groups? This is because if there is an error or mistake, this may cause transfusion reactions or HDN, which is hemolytic disease in newborns. This may interfere with cross-hatching. Now, for medico-legal parenthood problems. Now, what are the transfusion-related testing? Common tests used in immunohematology is the COM test, anti-globulin test, RBC typing, cross-matching antibody screening, and compatibility testing. Anti-globulin or COMS test remains the most important single test in AB detection. This is because what is its principle? Red blood cells sensitized by IgG or complement can be made to agglutinate by adding anti-human globule. Now, there are 2 kinds of COM test. The direct COM test detects RBC that have already been sensitized with IgG, and this demonstrates an in vivo coating of RBC by AB has occurred but does not identify the antibody. So this is an example. Patient, the antibody, then the cause of agglutination. So baby is positive, present on the mother's AB on the surface of RBC in erythroblastosis fetalis. Now, for the indirect comb test. What are their differences? The differences is its steps and its purpose. Detects antibody to RBC antigens present in the patient serum, detects in vitro red cell sensitization if red cells contain antigen corresponding to serum antibody. So procedure, step 1, the patient's serum with unknown AB plus RBC with known IgG. Step 2, product of step 1 plus the Combs reagent. This is the Combs reagent. Now this is very self-explanatory. Now, direct, this is their differences. Useful in detection of hemolytic disease of newborns, investigation of transfusion reactions, detection of autoimmune hemolytic anemia, detection of red cell sensitization by drugs, penicillin, ceftriaxone, alpha-methyldopa. Now, RBC typing. Forward typing, reverse typing, D antigen. Cross-matching, absence of agglutination or hemolysis essential to the safety of blood transfusion. Agglutination or hemolysis in any phase of the transfusion, or example, incompatibility, presence of AB and its corresponding AG. Cross-matching, its uses can be used to detect antibodies in the donor or recipient or to detect ABO typing discrepancies. Now for the fourth one, antibody screen. Where it can be used, it can be used to demonstrate unexpected antibodies in the serum of the recipient that may destroy donor RBCs that were thought to be compatible on the basis of the RH and ABO typing. This has replaced manual cross-matching. And last, pre-transfusion or compatibility testing. Review of recipient's blood bank history, ABO and RH typing of recipient and donor, antibody screening and recipient and donor serum, major cross-matching. Now, what is hemolytic disease of the newborn, HDN, which can also be referred as erythroblastosis fetalis? This occurs when the mother is alloimmunized to antigens found on the RBC of the fetus. This is because of the destruction of fetal RBCs by mother's IgG antibodies. So hemolytic disease, RH incompatibility, RHD negative, RHD plus cells, HD plus cells, and it invades the fetus. Therefore, they are incompatible because RH mother and RH plus baby. Therefore, ABO incompatibility, O mother and A or B baby. So after delivery, then subsequent pregnancy, then it will cause a hemolysis of fetal red cells. Now, HDN due to RH incompatibility. The setup is RH negative mother and the RH positive baby. RH negative person exposed to RH blood will develop reaction after 2 to 4 weeks. So mother develops antibody against the RH plus blood coming from the baby, and the first baby is not affected. HDN occurs during subsequent pregnancies. So this is an example on the HDN occurrences. As you can see here, this is negative, then the baby is plus. Then since it excretes positive antigens, therefore it makes antibodies for that positive RH positive blood cell. Then it causes anemia or hemoglobin degradation. Jaundice, kernisterus, which is the word we see that from the reactions, anemia, hypoxic injury to liver and heart, extramedullary hematopoiesis, hepatosplenomegaly, and hydrops. Healthy baby and baby with severe jaundice. As you can see, he is very yellow skinned. The kerniciterus. Now, HDN due to RH incompatibility may be prevented by giving anti-RH to RH negative mother in the antenatal 28 weeks and immediate postnatal period within 72 hours after delivery. ABO hemolytic diseases from the maternal fetal ABO incompatibility. A and B got IgM in blood which cannot cross placenta. OGT IgG cross placenta hemolytic disease. So, what are the complications of blood transfusion? Now, immunological, immunological or non-immunological. Then, infectious parameters: HIV, HBC, HCV, CMV, lepto, malaria, toxoleish, autologous blood transfusion. And for a simple recap and for conclusion, there is a last syndrome which is called the antiphospholipid antibody. Now, the antiphospholipid antibody syndrome is a constellation of clinical findings that are the result of antibodies produced against the phospholipids. Now, clinical manifestations can include stroke, myocardial infarction, and these are what we call from the complications of blood transfusion. And therefore, if it is not treated, more recent testings methods look for the presence of antibody-specific beta-2 glycoprotein and lupus anticoagulant. Now, treatment is based on the administration of anticoagulants, and treatment with immunosuppressive drugs has not been proven to be effective. So it is important to know the immunohematology of each of our blood because it can vary from the reaction, which is very fatal to the person. So I hope that you have learned many things this day and have fun learning. Have a great day and may God bless us all. Thank you.